Welcome to the DIY Honda Garage channel. DTC P2183 corresponds to an engine coolant temperature sensor issue, specifically the ECT sensor 2. This code indicates a performance problem or range issue within the ECT sensor 2 circuit. The engine control module, PCM, detects an abnormal temperature reading associated with ECT sensor 2 when compared to ECT sensor 1 and the intake air temperature, IAT sensor 1. Such discrepancies in readings suggest that the engine may not operate correctly, potentially affecting performance and emissions. The ECT sensors play a critical role in vehicle operation by monitoring the temperature of the engine coolant, which helps the PCM adjust fuel delivery and ignition timing accordingly. Proper functioning of these sensors is vital for engine efficiency and regulatory compliance. DTC P2183 indicates an issue specifically with the engine coolant temperature ECT sensor 2 circuit that is performing outside of its expected range. In this case, the PCM, or Powertrain Control Module, acts as the vehicle's brain, relying on input from various sensors to make real-time decisions about engine management. The ECT sensors, namely Sensor 1 and Sensor 2, are essential components positioned on the engine block, monitoring the coolant's temperature to ensure optimal performance. If the readings from ECT Sensor 2 are inconsistent with those from ECT Sensor 1 and the IAT Sensor 1, the PCM records this anomaly by storing the DTC. This malfunction could lead to poor engine performance, increased emissions, or operational issues if not addressed promptly. The P2183 DTC can arise from several potential causes. First, a faulty ECT sensor 2 is often the main culprit, where the sensor fails to provide accurate temperature readings to the PCM. Second, damaged wiring or loose connectors that connect sensor 2 to the PCM can cause signal interruptions or inconsistencies, leading to erroneous data being reported. Thirdly, a malfunction with ECT sensor 1 may also contribute to the issue. If its readings are invalid, the PCM may misinterpret the data from sensor 2 as well. Understanding these causes is crucial for timely and accurate diagnosis so that appropriate repairs can be made to restore sensor performance and ensure optimal engine functionality. Drivers may notice several symptoms that suggest the presence of DTC P2183. Poor engine performance is a primary concern. The PCM relies on accurate temperature readings to adjust the engine's fuel delivery and ignition timing. If the readings are inaccurate, this can lead to suboptimal performance. Additionally, increased fuel consumption may be observed due to improper fuel mixture adjustments that are a direct result of erroneous sensor data. The check engine light, or malfunction indicator lamp, MIL, is another common warning feature, alerting the driver that there is a problem that requires attention. Recognizing these symptoms early can help prevent further complications and improve driving efficiency. The first step in troubleshooting DTC P2183 involves turning the vehicle off for at least 6 hours. This allows the vehicle's components, particularly the ECT sensors, to reach a stable temperature condition. Following this period, start the engine and let it idle for at least 10 seconds. This step is crucial for allowing the engine coolant temperature sensors to provide a fresh temperature reading to the PCM, which will help determine if the issue is ongoing or if it was a temporary anomaly. This process helps to reset sensor conditions and is fundamental to ensuring that subsequent tests yield accurate results. The second step involves performing a visual inspection of the connectors for ECT sensor 1. It is essential to check for secure connections and loose terminals, as these can often be sources of intermittent faults. By ensuring that the wiring and connectors are intact and functioning correctly, you'll eliminate some of the simplest causes behind the DTC. Problems with connections can lead to erroneous signals being sent to the PCM. So this inspection is vital before moving on to more complex diagnostics or replacements. If any issues are found during this inspection, they should be addressed accordingly. Next, inspect ECT Sensor 1's functionality by starting the engine and allowing it to idle for approximately 10 minutes. The purpose of this test is to confirm that the temperature reading provided by the HDS or Honda Diagnostics System for ECT Sensor 1 exceeds 120 degrees Fahrenheit, 49 degrees Celsius. If the reading falls below this threshold, it indicates that ECT Sensor 1 may be malfunctioning, thereby contributing to abnormal readings detected by the PCM. A proper functioning sensor is crucial for accurate temperature data, impacting engine performance. Monitoring this step closely provides insights into whether the first sensor is contributing to the DTC P2183 issue. The fourth troubleshooting procedure focuses on ECT Sensor 2. Begin by starting the engine and allowing it to idle for around 10 minutes, just as with ECT Sensor 1. You will again use the Honda Diagnostic System to confirm that the reading for ECT Sensor 2 also exceeds 120 degrees Fahrenheit, 49 degrees Celsius. An output that does not meet this requirement indicates a malfunction within ECT Sensor 2 itself. Monitoring the functionality of both ECT sensors provides a comprehensive view of the system, as it could further pinpoint the specific sensor causing the circuit performance issue logged by the DTC. Correcting issues in this area is critical for restoring vehicle performance. For the fifth step, both ECT Sensor 1 and ECT Sensor 2 must be allowed to cool down to the ambient temperature. After this cooling process, take note of the ambient temperature for accurate comparisons. Once cooled, turn the vehicle to the on mode and quickly check the recorded readings of both sensors via HDS. The normal operational condition dictates that the difference between the readings of ECT Sensor 1 or 2 should be less than 5.4 degrees Fahrenheit or 3 degrees Celsius from the noted ambient temperature. If the difference exceeds this value, it indicates issues with either ECT Sensor 1 or ECT Sensor 2, or potentially both, necessitating further diagnostic or replacement actions. After completing all repair procedures related to DTC P2183, it is crucial to perform a final verification of the repairs made. Begin by clearing any DTC codes stored in the PCM to ensure a fresh start for testing. After clearing the codes, monitor the vehicle for a defined period to confirm that the ECT sensors, both Sensor 1 and Sensor 2, operate normally after the intervention. This may involve restarting the engine and observing the immediate outputs on HDS. A clearance of the DTC, alongside consistent and accurate sensor readings, would confirm the issue has been resolved, thereby ensuring the vehicle's engine operates efficiently and effectively without further anomalies. Preventive maintenance is crucial in ensuring that DTC P2183 does not recur. A regular check of the ECT sensors should be part of scheduled maintenance routines. This involves inspecting the sensors for signs of wear and ensuring they are clean and functioning correctly. Additionally, the wiring and connectors associated with these sensors must be routinely checked for signs of corrosion, fraying, or loose connections. Proactive inspection and maintenance of these components can help prevent future performance issues related to temperature readings, ultimately extending the life and reliability of the engine's performance. In summary, DTC P2183 indicates a performance problem with engine coolant temperature sensor 2, making it critical to diagnose and resolve issues promptly to avoid further engine complications. Proper troubleshooting involves a series of steps, from checking sensor functionality to ensuring secure connections and inspecting for any faults. By following the outlined diagnostic steps accurately, technicians can ensure that either ECT sensor 1 or sensor 2, or both, are functioning correctly, which is essential for vehicle efficiency. Additionally, employing preventive maintenance practices can significantly diminish the likelihood of recurrence. Understanding the implications of such DTC codes can aid owners in taking the necessary actions to maintain optimal vehicle performance over time. Please like and subscribe to the channel. See you next time.